Hey, folks. Hello and welcome to Service Mesh Academy. Flynn, do you mind giving us a quick introduction about what we're going to be talking about today?
We're going to be talking about mutual TLS on Kubernetes with Linkerd. I want to open with a bit of an apology. I'm kind of under the weather, so I might not be up to my usual 100% something or other, but we'll see how it goes. Also, this is our inaugural live stream with Restream rather than just Zoom. We would always like to have feedback on how things are going, but we especially would like feedback on how this platform works out this time around, because we think we're going to do this one going forward. And with that, back to you, Jason.
Yeah. So on that note, you may be watching on Twitch, on YouTube, on LinkedIn, any number of places. The best way to chat with us and other folks from the Buoyant team that are watching is to join the workshops channel in the Linkerd Slack, and that is slack.linkerd.io. Okay, so today it'd be great if you are in chat. Love to hear a little bit about where folks are from. Yeah, love to hear a little bit about where folks are from, where you're joining us. Where you're joining us from. I myself is in Washington, D.C. Flynn is up in Boston.
Yep.
And
where it's actually above freezing.
There you go. Yeah, and with that, the recording for this is going to be available later. So let's
I think
go
on all
ahead.
The platforms, right?
So, yeah, it's going to be available in a bunch of places, and of course, you're going to be able to find it in a recap email that we send to attendees. Yep. So why don't we get started?
Let's take it away. So, yeah, I'm Flynn. I'm a tech evangelist for Buoyant, specializing in Linkerd. You can email me. It's flynn@buoyant.io, but really the best way to reach me is probably just to hit the Slack where I'm at Flynn. On the agenda for today, we're going to talk a little bit about authentication because it's an important building block for all of this. We're going to then go into some details about TLS and then into mTLS, and then we're going to do hands-on demo for mTLS in practice. Hopefully. It might just break horribly, but I don't think so. I think we're going to be okay. If you want to follow along with the hands-on part, and we hope you do, you can always just watch this, but it's much more fun to try to break everything on your own. You will need a Kubernetes cluster. I personally am going to be doing this with K3D, but the actual kind of cluster you use really doesn't much matter for this. You'll also need the kubectl CLI and the Linkerd CLI. And you will be able to you can already check out the workshop sources in the Buoyant.io Service Mesh Academy repo in the mTLS workshop directory. This time around, we have an optional homework assignment as well. So hopefully y'all will go ahead and poke at that a little bit too. Okay. And just since I didn't say it before, yes, if you go through and put stuff in the chat, we should see it, whatever platform you're chatting to us on. And if you put stuff in the workshops channel in Slack, we will definitely see it and can address questions that way. All right, so let's talk a little bit about authentication. Authentication tends to be not always that well understood. One of the particular ways that people tend to get confused is by mixing up authentication and authorization. Those of you who have seen me do the certificate management workshop, this should be very familiar, but in case you haven't, we're going to go over it quickly. Authentication, authn, is all about knowing who the entity with whom you're communicating is. Authorization, authz, is about knowing what that entity is allowed to do. In human terms, for example, authn is knowing that I can look up here at the little window and know that that really is Jason. And authz is all about, do I think it's okay to loan him 20 bucks? For the record, I do, just so you know. But that's the difference of what we're talking about. One is about who you are. One is about what's okay for you to do and how much people trust you. It is very important to realize that neither authentication nor encryption by themselves are enough to have real security in communications. They are building blocks. They are very important building blocks, but they're not sufficient. For proper communication security, you need to be able to guarantee confidentiality, which is to say, if I'm talking to Jason, then only Jason should be able to understand what I'm saying. That's where encryption comes in. You need to guarantee integrity. So if I'm talking to Jason, what I say is what Jason should receive. That is actually a building block kind of underneath the authentication layer, typically called a MAC, an access check. We're not going to talk about that much today. Finally, you need availability, which is whatever I'm supposed to be able to talk to Jason about, we need to be able to actually do that. And we need to also know that it's okay to talk to Jason about this stuff. That's kind of where Auth-N and Auth-Z come in. But you really do need all three of these things to have communication security in practice. And we're starting off talking about authentication because it's extremely foundational to all this stuff. It's not really meaningful to be trying to talk about secure communications if you don't know who you're talking to. If I go through and I encrypt everything using Jason's private key and I send it off, and then I find out that the key that I thought was Jason's private key actually belongs to Catherine, it doesn't actually matter what the other stuff I've done. Jason won't be able to see it, but Catherine will, and that will be a bad thing. So all of that is kind of the whirlwind tour of the building blocks that go into TLS. TLS itself is really a solution for managing everything, managing secure communications from one end to the other. It is basically a scheme where a client can talk to a server, even if they haven't ever talked before. Note that I'm talking about TLS without the M on the front here. So in practice, what tends to happen here is that the client will go through and talk to the server. We'll make sure that the server it's talking to is really who it thinks it's talking to, and then they'll do a negotiation to set up encryption and integrity checks so that they can communicate safely. If we dive a little bit deeper into that, then there's a fairly complex protocol that happens here. It opens up with the client making a connection to the server. And there are a couple of different ways where it can basically be saying, hey, I want to do TLS as opposed to something else. But the client will initiate the connection. The server will then send back and say, okay, here's my certificate so that you can authenticate me. The client will then decide whether or not the server is really who it thinks it is and whether this is an okay server to talk to. And then this here's an encryption secret thing is actually a little bit of a misnomer. What really happens is that both ends exchange information that is not the key. It is other information from which they can construct a key. So the encryption key you actually use to secure the data is never sent over the wire. Then after that happens, they go through and they can communicate securely because they have authentication, they have integrity, they have encryption. Because of the way all this is put together, we have some kind of interesting properties that are important to know about TLS. The first one is it's implemented on TCP. It is a connection-oriented protocol. At some point next year, we will have to do a Service Mesh Academy where we talk about HTTP 3. HTTP 3 is based on UDP, not TCP. And the world is very, very different at the protocol level. So we'll end up talking about that sometime next year. TLS is based on asymmetric cryptography. This whole business of being able to do the authentication and then exchange encryption information requires that you be doing this in a world where you have one key to encrypt data and a different key to decrypt data. And this is fundamental. We're not going to go and dig too much into exactly the details of how this works unless we have time for questions later. But just know that you can't do TLS unless you have asymmetric cryptography in play. The setup, you'll often hear people including me, you'll hear people talk about TLS handshakes. That's the broad name for that whole thing at the beginning of the protocol where you go through and do the negotiation of encryption keys and protocols and all that stuff. And that implies that when you make a TLS connection, there's a certain cost in latency to doing that handshake. So TLS also has the interesting property that you would really like to be using it with protocols that can keep the stream alive and do multiple requests over a single connection. So HTTP 2, great. gRPC, great. HTTP 1.0, a lot less great. But there are other reasons why you don't want to really be using HTTP 1. Finally, authentication relies on certificates and public keys, and really private keys. As the name might imply, private keys should be kept private. Public keys, not only is it okay for them to be public, you really want them to be public and widely distributed so that authentication can work easily. This is one of the things actually that Linkerd mostly handles for you underneath. Okay. So this is the point where I normally say things like, are there any questions? Given that we know that there's a bit of a delay on the chat, I'm just going to continue going, but feedback about whether this explanation is making sense is always great. Jason, were you about to say that there are questions on Slack or something?
There aren't, but it is a great time to remind folks, if you're watching, if you post a question in Slack, on Twitch, on YouTube, I'll interrupt Flynn. You'll see a little bit of a delay. I'll interrupt Flynn and we'll get to your question. So please share them as they come up. And
Yep.
sorry, back to you.
Yeah, that's fine. Okay, so let's go on and talk about mTLS, having reminded folks about questions. mTLS, the M stands for mutual. It is exactly the same protocol. The only difference is that with mTLS, not only does the client authenticate the server also authenticates the client. This is important for a lot of reasons, but one of the biggest reasons that it's important in a service mesh is that it is the thing that enables you to do authentication based on the client. It is the thing that enables you to do stuff like Linkerd's route-based policy, where you can say things like, oh, this workload gets to talk to this other workload, and you can always be sure of the originating workload's identity. So if we go and look a little bit further at a high level, this is kind of the same, except that where previously we just had the client asking if the server was who it is, there's a new step 2 where the client also has to transmit a certificate, and the server will then come back and say, oh yeah, you're all right. Interesting point about the protocol. The client does not hand over its certificate first. The server has to hand over its certificate first. The idea here is that the protocol is designed from the idea that you would like to protect the client more than the server in some ways, which is a little interesting. But after you go through and exchange certificates and do all the encryption handshake and everything like that, then you're right back into secure communication, exactly like TLS without the M. Okay. I've been talking a lot about certificates, and really quickly, a certificate, you can think of it kind of like a driver's license in the real world. It states your identity and also provides some information by which an interested party can verify your identity. For driver's licenses, that's mostly just that we know as a society that they're tough to forge. But I mean, you could take a driver's license to the issuing people and ask them if it was a real one. We just tend not to because it's expensive. In TLS, we do actually check every time. The protocol is designed for that. The certificate states the identity and is signed by an issuer. And there's a chain that goes all the way up to eventually there's some central authority or some trust anchor in Linkerd is what it's called. That is sort of the root of all trust for this particular system. And every time you will go through, get a certificate, and then walk the links up to the trust anchor to make sure that everything is okay. Okay, this happens at the protocol level. You don't typically have to worry about that as a user. In Linkerd, we associate certificates with individual workloads, and ultimately we would derive them from Kubernetes service accounts. There are a couple of reasons that we do that. The biggest ones are that our users are typically already accustomed to using service accounts for things. And the other thing is that the service account token gives us some bootstrapping information that we can use to create a proper cryptographic identity that is then associated only with that service account and cannot be associated with anyone else. Also worth noting that I mentioned that every time you go through and you verify the trust all the way up the chain. So Linkerd automatically handles rotating certificates for workloads, making sure that they're not used for too long a period of time and making sure that they get renewed before they expire. Linkerd also gives you tools for managing the rest of the chain, or you can use something like Cert Manager or other solutions like that. In production, we would rather recommend something like Cert Manager rather than doing this by hand. If you do it by hand and you forget to rotate one of the certificates before it expires, you end up taking downtime. There's nothing you can do about that. So automation is a good thing here. All right, all of this leaves us at Buoyant believing that mTLS is hands down the best way to handle zero trust security. There are a couple of reasons for that. And again, if you've watched much of anything that we've done before, you'll have heard these things. One of the biggest ones is that identity can be associated with the workload rather than being associated with something in the network. So if you don't do mTLS cryptographic identities, you often have to associate identity with something in the network like an IP address. That can work okay back in the bad old days when we had complete control over IP addresses and network topology. And in Kubernetes, we don't have that kind of control anymore. If a pod goes down and gets restarted, its IP address can change. So that is a problem. Another thing we like about associating identity with the workload and ultimately with a service account is that way the security model of the identities already matches the mechanisms that have existed in Kubernetes since the beginning. People understand service accounts. They may not particularly like the way they work, but they're well understood. And you end up being able to associate a certificate with a thing in Kubernetes that already has a defined security scope and lifecycle and all of that. So it can be very simple to work with the tools that are already a part of Kubernetes. Since identity is no longer tied to the network, that means it's no longer tied to a particular cluster topology. And that means we can do things like mTLS across clusters for multi-cluster, and it's really easy to do that. Another thing that's nice about this one is if you set it up correctly, then if you lose a secret, you always have a path to recovery. And most of the time, that path does not involve downtime if you catch it quickly enough. Here, lose could mean a certificate that expires, but it could also mean if you find out that one of your certificates was compromised, you can usually just go ahead and rotate that and nobody has to be the wiser. Okay. Whoops. Excuse me. Is this all you need? In some cases, yes. mTLS protects very effectively against a lot of different kinds of attacks. That on-path attack is what we sometimes call the man in the middle. Imagine you have an attacker who is sitting on the network in a place where they get to intercept traffic from me to Jason and then send it on to Jason. mTLS does a great job of preventing that attacker from being able to do anything because as long as the attacker has not also stolen Jason's keys, the attacker can't go through, decrypt things, modify them, et cetera, et cetera. They can block the traffic, but that's okay. I'll know about that. They can alter traffic, but the integrity checks will let me know about that too. And that is a very effective tool to blocking those sorts of attacks. Same thing applies if you have an attacker pretending to be me. If Catherine goes through and talks to Jason and says, "Oh, yeah, I'm totally Flynn," Catherine will not have my private key, so she won't be able to do anything. We can also do things with mTLS since we're doing client authentication. That gives us a path to block unauthenticated API requests from reaching a workload. And you see this in the route-based policy workshop or the zero trust workshop, where we start by setting up a given namespace so that only traffic within that namespace is allowed. And then we go through and gradually open up traffic from outside to be able to do certain things that we want while preventing things that we don't want. Okay, what can mTLS not do? All right. Some of these are true everywhere. Some of these are only true in Kubernetes. But in Kubernetes, because of the way Kubernetes networking works, if your attacker can get access to localhost, by which I mean they have RBAC permissions to go and execute a process on a container within a pod, they can run any of various network tools and they can intercept traffic as it passes around the localhost network. There's not a lot that Kubernetes or mTLS can do to prevent this particular behavior. It has to do with the way the network topologies and the network drivers work within Kubernetes itself. Likewise, if you have an attacker that can get access to the Kubernetes node on which your pod is running, an attacker may be able to get access to the keys that are being used to secure mTLS communications passing through pods on that node. That's a pretty big might. It requires a certain amount of effort to get this one done, and it's not the most straightforward thing in the world. But you should probably assume that somebody who can get access to the node would be able to do this, and lock down your nodes so that people who aren't supposed to have access to them don't have access to them. Finally, mTLS is all about communications. So mTLS encrypts data in transit, but it will not encrypt data at rest. So if you have a database, for example, then mTLS can protect communications where people are making requests of the database, but it will not protect the data in the tables on the disk that the database is reading from. That's an entirely different animal, and that's completely out of scope for this talk. All right, it's demo time. Jason, do we have any questions in Slack? Do we have any feedback on Slack?
We have a question, but I told them that you can get back to it after the workshop because it's a little bit niche. Other
Okay.
folks, if you have any other questions, looking forward to hearing from you.
Absolutely.
Yeah, I'd say let's roll through into the demo.
Off we go. They say never precede a software engineering demo with a comment more predictive than watch this. So yeah, watch this. Keep your fingers crossed. All right, so this demo here, we're going to start by deploying Linkerd to a cluster. I already have my cluster running. We're going to inject a couple of example workloads, and then we're going to go through and we're actually going to do the thing where we go in and use a network snooper to watch traffic flowing around on the cluster and see what happens. All right. So like I said, I already have my mTLS cluster. It is a K3D cluster with one node, just for those who are curious. If you look in the repo for this workshop, you will find create.md, which shows you exactly how I created that K3D cluster. And we're next going to go and install Linkerd. This is your typical Linkerd 2.12 install. We do the CRDs, then we do Linkerd itself. I am not going to lie. I'm actually running 2.12.2 instead of 2.12.3, and that will become somewhat relevant later when we see things. Sorry, I wanted to upgrade to 2.12.3, but I also wanted to go and make certain that I could test everything before doing it, and I ran out of time. All right. I'm also a little disappointed by my name covering up that. I wonder if I can turn my name off since everybody probably knows who I am. I'm not going to worry about it. That says Linkerd viz install pipe to control apply -f like that. Okay. So finally, we wait for everything to be ready by running Linkerd check. And this is going to go through. Yep. See, there you go. It's complaining because I'm running 2.12.2 and not 2.12.3. Sorry, everybody. Totally my fault. But that got us all the way through. Linkerd's core is happy and running. And now we're running the viz extension check. I guess while it's doing this, I'm going to see if I can turn my name off. Does not look like it. All right. Well, I'm just not going to worry about that then. So that took a little bit just because we were waiting for the viz extension pods to come up. And we are going to use Linkerd viz. I would always encourage you to install Linkerd viz. It's a really, really useful tool, but we are definitely going to use it for this for sure. All right. So everything should be ready to go at this point. So next thing we're going to do is we're going to actually use a tool called Tshark to go and snoop network traffic flowing between pods on this network. The easiest way to get Tshark installed is via the handy dandy Linkerd debug sidecar, which we provide. You can install this by providing an annotation on a meshed workload. We're actually going to do it a little bit differently because we're going to start off with an unmeshed workload so we can see what's going on. So first thing we're going to do here is we're going to install a curl deployment. The curl deployment is really, really nothing magic. It's literally just we pull in the curl image and sleep for a year or 10 years. 10 years. I don't believe I've ever seen that before. Anyway, so let's go ahead and get that installed. We are going to install our curl pod and we're going to inject it into Linkerd's mesh. So curl is actually fully able to participate in the mesh in all ways, and we would expect it to want to do mTLS, right? Next thing we're going to do is we're going to fire up Nginx. We have a service for Nginx. Where's my mouse? We have a service here. It's not very profound. And then we also have the Nginx deployment itself, where if you'll note, we are actually including the debug sidecar container in our Nginx deployment to start. The reason for that is if we didn't, we are deploying this without injecting it into the mesh. So if we tried to use that annotation that I mentioned earlier, since Linkerd wouldn't be injected, Linkerd wouldn't be able to read the annotation and put in the sidecar for us. So we have to do this by hand because we're starting off with this not meshed. So let's get that going. Okay. So I'm next going to go through and talk about how do we check to make sure whether TLS is happening, but there's a bit of a spoiler alert here. And the reason is if we run Linkerd viz dashboard, then if we come over here and look at this, you can actually just look at the default namespace and say, oh, hey, look, Nginx isn't in the mesh. So you already know that it's not going to be doing mTLS at this point, and you know that curl is going to try to. So this is an example where we're going to go through and do it the low-level way as well, but don't forget about viz. It can be a really, really handy tool sometimes. All right. So we come back over here. Next thing we need to do is we're going to get tshark going. And the way we're going to run tshark is we're actually going to use kubectl exec to run tshark in the debug sidecar container of our Nginx deployment. And that requires that we have the name of the Nginx pod to start with. So we can go ahead and get that, our lovely complex name here. And we're going to use a second, I said a second window, but I'm really going to use a second tab for this to go through and run tshark. So if I come over here, all right, so that's capturing. Then we come back over here, and the next thing we're going to do is we're going to use kubectl exec again to run a really simple curl request from our curl pod. All we're going to do here is we are going to curl from our curl pod to the Nginx pod. Very profound. So we were able to talk to Nginx. That's great. And now we can go back and look at our tshark window. And in fact, we can see that this was 100% not TLS because we get to see the data flowing over here. For those of you who have fun looking at TCP stuff, we get to see ARPs. We get to see the three-way handshake at the start of the TCP connection. And then we get to see HTTP traffic flowing. I'm not going to go through and dig too far into this, but I am going to point out two things. One is we got traffic going from 10.42.0.11 to 10.42.0.13. Remember those numbers. .11 is the curl pod. .13 is the Nginx pod. There will not be a quiz on this later. So back over here, like I said, you can see that that's happening in clear text. And now we're going to go through and inject the Nginx pod so that it actually gets to participate in the mesh. And then hopefully we'll be able to see that it's no longer clear text, right? So we did that. Let's wait for Nginx to restart. Nginx is restarted. Wow, that was nice and quick. Okay. The Nginx pod just changed because it restarted, which means it has a different name now. So we have to go ahead and get that. And next, we're going to use the new name. This is the new name, not the old name. We're going to use the new name to run tshark again, but this time we're going to grep out traffic to 127.0.0.1 as described up here. The reason for this is that, remember, we get to see all the network traffic flowing around in this container, not just, in this pod, not just our one container. So that means we would be able to see the traffic from the Linkerd proxy to the Nginx pod as well. And that will happen on 127.0.0.1. That's not what we're interested in seeing because we already know that's going to be clear text. What we're interested in seeing is traffic between the Linkerd proxies. So back to the other terminal, get that going, and then you can already see some TLS going on in here. That's kind of nice. You can also see that there's some non-TLS. This is actually Kubernetes liveness checks, which are always not TLS. Okay, so let's send another request. Same thing again from our curl pod, which has not changed its identity. That worked. Let's go back and look at T-Shark, and we can still go through and see a bunch of TLS application data happening around here, including, I had to scroll pretty far back for that, but we can see from .11, and now the curl pod is .14 because it's just changed its identity. You remember what I was saying earlier about how we think mTLS is important because it's not tied to network characteristics? Here's a great example of why. The network changes a lot when you do things in Kubernetes. But here, TLS application data, TLS application data. So we don't get to see anything about what's going on here. We just get to see that it's encrypted. All right. As usual, if there are questions, this is a good time to throw them out.
Yeah, actually, we have a great question about essentially. So, one of our watchers is asking, or one of the viewers is asking about. They've got applications like a Node.js application or something, and they're wondering how would they handle using the fact that Linkerd in the sidecar proxy is like generating and using a certificate for mTLS traffic. How would they use that with their individual applications, and do they need to import these Linkerd certificates into their app to use them?
That is a fascinatingly advanced question. The interesting thing here is that once you mesh this, the communications that you're going to get from Linkerd's proxy will be clear text. You won't see the certificate at all. And I think probably the best thing to do is to hold off on that question, and we can come back and talk a little bit more about that. But one of the things that's really interesting about all of this stuff is that part of the point of the service mesh is to insulate your application from the details of this level of mTLS. So typically what we see is people building application layer user authentication above the workload authentication. And yeah, let's remember to come back to that a little bit towards the end, because that is a great question.
Great.
Anything else?
No, that's the big one.
Okay. All right. So let's go take another look at Linkerd Viz now. And Linkerd Viz, if it lives up to its reputation, we should be able to go through and use Linkerd Viz to see some more things about this traffic happening as well, right? So we'll kill T-Shark over here, and we'll run Linkerd Viz dashboard, which is exactly the sort of thing that I really don't like doing a whole lot of, but it's easier in this case. I prefer to just set up an ingress controller for all this stuff, but it's a little simpler if we don't do that for this particular demo. All right, so here is our Viz dashboard, and we can see that now you can see traffic happening between curl and Nginx. You can see that they're both meshed, all good. And if we click in here, we can actually see live calls happening. So we can come back over here and run another curl, and then we can see what happens in the Viz dashboard. So if we flip back to Viz, you can actually see that this traffic came in from curl, it came in over here, and there's not a lot in this particular window that tells us whether this was TLS or not, right? So this is one of those points where I'm kind of going to show you some stuff that I would be happier to show this a little bit differently, but well, you know, I want to make sure everybody knows about this one. If we click on this little microscope over here, then that will get us into the tap section of the UI. We can start a tap, and now we'll be getting down here where it says no data to display yet. We'll be getting very detailed information in theory about what's going on. So we'll go ahead and run another request. I got a little bit ahead of the script there. So sorry. All right. So if we come back here, now we see this, and there's this disclosure triangle that's supposed to give us a lot of details about the communications, right? If we click on that, we do get a lot of details about communications. And unfortunately, if you look through this screen, you will realize that nothing in it says whether TLS was active or not, which makes me very sad. And I think we're going to have to go through and see about adding that. But this is, well, okay, so first off, this L5 dest canonical thing is a little bit of a proxy that can make you feel a little bit better about this one, but still, this is kind of not what we'd really like. This is not going to make anybody feel terribly good. Fortunately, there's another way. We can actually go through and run viztap from the command line. And if we run viztap from the command line and pick the JSON output, it will go through and give us a lot more information. Yet another request. And if we come back over here now we have a ton of information. And if we scroll all the way up to the top of this, we can see, okay, here's our source, the infamous .11 again. It actually identifies this as being a curl pod. TLS is looped back here by way of saying the proxy is speaking, or the curl process talked to the local proxy via the loopback interface. The destination is .14, that's an Nginx pod, and it was using TLS. And we can be certain that this is, in fact, the request going outward by looking at the outbound side of this, and we see a request init event. If we scroll further down, you'll see the same sort of thing, but this is a response event, and you can see that this is also TLS. So this is one of the not terribly common examples where doing things in the CLI actually does end up working out a little bit better than doing it in this particular chunk of GUI. All right. Again, do we have any questions so far?
Nope.
Okay.
Things seem to be flowing smoothly.
We might actually end up being early. How creepy is that? All right, but let's take a quick look back over the whole thing, because this really was kind of messy when you get down to it. We started off by verifying that uninjected traffic was not using TLS, right? If you want to take a close look at uninjected traffic, you have a few options. They're kind of limited. You can use things like ksniff, which has a privilege concern. You have to have elevated privileges to run them. You have to learn new different tools. T-Shark kind of falls into this as well. You can use things like ephemeral containers, which honestly are even a little bit weirder because you might need the cluster provider to set stuff up for you ahead of time and then still have to deal with privileges. As we did earlier, you can use the debug sidecar. All of these, no matter what you want to do here, if you're trying to snoop on this stuff that's uninjected, then there's a bit of a problem in that you have to deal with privilege on the cluster. You have to be able to inject this debugging tool, but also the debugging tool has to have access to network admin capabilities so that it can do its thing. And there are a lot of runtimes and a lot of clusters where that's just not going to happen. If you're verifying injected traffic, this gets to be a little bit simpler. The debug sidecar is effective, but it's still very clumsy. Linkerd viz top is kind of less clumsy. You get to zero in on the traffic you want. You do get some very voluminous JSON output. You know, that's kind of not ideal. But there is a simpler way, which is that we can just go ahead and use Buoyant Cloud, and that makes this trivial. So, excuse me. If we flip over to Buoyant Cloud here, and if y'all have not seen Buoyant Cloud before, well, it's pretty cool. So this is an overview where we're looking at one cluster, we're looking at a bunch of stuff. The interesting thing for our purposes, though, is we can click into this topology view. And let's pick one of these and zero in on this. This is our Bookzap workload. Now, normally, if you look at these edges here, they're labeled with the success rate of all the traffic. But if we want to, let's turn on the port view just for the fun of it. We can see which ports all this is happening on to, and we can change the edge labels to be TLS. And instantly they all turn green and say mTLS, and we can just look at this and go, hey, this is all mTLS. And that is definitely simpler than anything else we could do with these other tools. So that's actually it for the demo. Well, since the slide is up, next year, oh my God, 2023 already. In January, we're going to be talking about Linkerd and Ingress controllers. We're going to talk with, going to show things off with Emissary, Ingress, and Nginx, and probably even play with the shiny new demo of the Envoy Gateway. And then on February 16th is the second of a two-part series where we'll be talking with Weaveworks about Weave and GitOps and Flagger and Linkerd and all sorts of cool things like that. And now would be an excellent time to go back and check in on some of those other questions.
Yeah, so we're still actually still in actually pretty good shape. So we just had a question again from a viewer about like what do they need? So they're looking to get started. They're using AKS, and specifically they're going to be in a private cluster, and they're using Calico. So are there any big considerations to look at?
Gut feel? No, just try it and see what happens. Since Calico is involved, I have to put a little bit of a caveat on that. As we discussed back in was it just the previous workshop, the deep dive on startup? There's a workshop out there, the deep dive about startup. And as we discussed in that one, when you're starting things up, there's a lot of network configuration that has to happen. That can happen either with an init controller, which requires certain capabilities, or it can happen with a CNI plugin. With Calico, you might actually need to use the CNI plugin. I'm not 100% sure on that, but it's definitely, if you try it just in the normal way and you're finding that your pods aren't coming up, switch to the CNI plugin and see what happens.
Yeah, so a bit of answer just because I happen to have seen Calico a lot. The Getting Started Guide gives you everything you need to just get started with Linkerd. And beyond that, there's also Buoyant produces a Linkerd production runbook. So if you're going to get going and you want to answer these questions, hey, what do I do about storing metrics, or what things do I have to be prepared for as I go, including under what circumstances should you look at using the CNI plugin in place of standard Linkerd init containers. A lot of that is covered in that guide.
There's a lot of really good stuff in that guide.
Yeah, and we have another question from Kevin about what considerations should you keep in mind when you're looking at multi-cluster and Linkerd, especially from an mTLS perspective.
There's one huge one. There's one huge one, and there's one somewhat less huge one. The less huge one, let's tackle that one first. Your multi-cluster clusters have to be able to talk to each other over IP. I realize that's probably obvious, but it bears repeating. In particular, this can be a thing where if you're trying to set up a proof of concept of multi-cluster with K3D, you have to be very careful about that. Network, then it's usually less of a concern. The clusters must also share the same trust anchor. And there is, in fact, a multi-cluster failover workshop. Maybe that was the previous workshop. Yeah, so we do these every month. And in case you can't tell, then after a little while, they all kind of get out of order and blur together. But we have done the workshop on multi-cluster failover and all that, and we talk at great detail about how to set up this stuff. So I would strongly encourage you to check that out. You can either watch the video or you can look in the, I think it's just called the multi-cluster failover directory. There's a directory in the Service Mesh Academy called multi-cluster failover, and you can look in that and get a bunch more information about that too.
As Flynn mentioned, there are actually a bunch of these recordings out there. And if you look on the screen right now, buoyant.io/SMA, you're going to get a list of what's coming up, like Linkerd and Ingress controllers, and what recordings we've done in the past, including things that cover Linkerd certificate architecture, which is a really important part of multi-cluster, which is really the question you asked. Oh, thank you so much for sharing that, Flynn.
And you get to look at William too. Yeah, all the upcoming stuff. And then this is all the stuff that we've done in the past. Oh, excuse me. The multi-cluster fail one was actually a CNCF live stream, not a recent Service Mesh Academy. But here is the Service Mesh Academy version from back in July. So, anything else?
It looks like we have someone typing a question right now, but that's all we're looking at.
Okay.
Oh, we might as well go back to I think it was Seth whose question.
Oh, right. The question about application. Well, wait, sorry. Was that the question about applications, or was that the one you said you wanted to get back to later?
It was the one we said to get back to later. This was about, how do they, and really should they, try and take like Linkerd certificates and use them with their app. And of course, the short answer is, right, like you saw Flynn do, right? When you're using Linkerd mesh, right, like your applications are going to think they're communicating over plain text. Like they're not aware of the TLS, the mTLS, the metrics, retries, all these things become transparent to the applications and are handled by the proxy. I'm sorry, Flynn, I didn't mean to.
No, I was gonna say pretty much exactly that. The typical way you see people tackle this in the real world is to have the ingress controller doing whatever user authentication for the application and then passing things through in headers or other stuff like that. Because the ingress controller can be the bridge between the outside unmeshed world and your meshed workloads. And once you get stuff into the mesh, you've got secure communications. So it's okay to trust things like headers for important stuff.
Yeah, great.
Yeah. It is a really, really interesting question, though. And it's definitely one where it would be interesting if you've got a particular use case where it would be really, really handy to be able to do this differently. We'd love to hear about that.
Yeah. Yeah, great. Beyond that, we have a couple of specific questions, folks. If you're in the chat, if you're looking for help with like a particular issue that you're seeing in your environment, you're much better off going into the Linkerd 2 channel in the Linkerd Slack. Again, that is slack.linkerd.io. Join in and just ask folks questions about particular implementation details there.
There's the link on the bottom, although as Jason points out, that would be the Linkerd 2 channel rather than the workshops channel. Ooh, right. Wow, we misspelled workshops. That's depressing.
Oops.
I'm gonna fix that.
Yeah. Well, I guess everybody, thanks so much for attending. We're really, really grateful for you spending the time with us.
Yeah. Jason, was there another question from earlier that you mentioned earlier that there was another question that you'd said, oh, let's come back to that. Was that the application level auth question, or was that? Okay, cool.
I think so, yeah.
Just wanted to make sure we'd gotten that.
Although the problem with forgetting is you don't know what it was that you forgot.
Well, yeah.
But I'm fairly sure it's that.
If it wasn't, ask the question again, because we got a few more seconds where we can go through and talk about some of this other stuff. We talked a little bit about the upcoming Service Mesh Academy workshops where we hope to see y'all again. I showed a little bit of Buoyant Cloud. We would be happy to show you about Buoyant Cloud. You can book a demo at buoyant.io/demo. And you can always reach me, again, Flynn at buoyant.io or at Flynn on the Linkerd Slack. And you can also reach Buoyant via Twitter and the web and, all those useful things like that. Go ahead.
Great question from Kevin. So what do we think as far as like additional latency that you get using mTLS? So if I have, if I were communicating plain text between my applications and now suddenly every request, say I've got like a REST, I'm talking to a REST API, every session I have to build up a mutual TLS. Like what is the implications of that for the performance of my application?
In practical terms, not a whole lot. Jason, you might actually remember some of the numbers that people have seen better than I do, but I seem to recall it's like down a millisecond or so. Part of that is simply that the proxies can do this very quickly these days and networks are quick. But another one is that most of the time in the real world, you get to reuse the connections and issue multiple requests over the same connection. So your latency the mTLS latency is actually amortized across many connections rather than doing it with a single connection. If you are stuck using HTTP 1.0 and you must make a new connection every time. Yeah, I mean, you could possibly see some real latency there. I'm going to argue that it would still be worth it for the security, unless there's some really, really surreal stuff going on where we need to know a lot more about the application. You would
Another
say?
advantage of using Linkerd is that the proxy. So while your application may build a connection on every request,
Oh,
the
yeah,
Linkerd
great point.
proxies build a persistent mTLS connection between your clients and your servers, right? So that you're not seeing an mTLS session get established on every new connection.
Yeah. The that's particularly important for things like gRPC and such, where we get to do request level load balancing no matter what the application is doing.
Yeah. Uh, Seth was asking some questions around tuning, right? So one
Okay.
of the things that we talk a lot about with Linkerd when we're talking to Linkerd adopters, right, is that the default behavior of the proxy, right, is what we would recommend all the time, and we don't think that you should be going in and trying to tune things about the way they do mTLS, but instead allow your connections to just go in plain text from application to application, and in the middle, that Linkerd proxy by being by being in the same network namespace as your application, it can handle all that encryption and all that configuration.
Right.
And your app developers get to worry about application functionality, not
Not network crap.
right.
Yeah. One big thing that you kind of do need to think about in terms of tuning is the lifespan of the certificates. That's where I'd be thinking about that sort of thing. Like Linkerd handles the rotation of workload certificates for you. There's an there are two certificates above that that you are more responsible for rotating, and I would encourage people to think a little bit about the lifespans of those, because when you install Linkerd from the command line, they have very long lifespans, and that might or might not be appropriate for a given application.
Yeah, great point, Flynn. And if you have questions about production readiness for Linkerd, one, there's a SMA episode where we talk about productionalizing Linkerd. Another one is the production runbook from Buoyant is really intended to force you to answer a number of questions about what do you need to do to ensure that you can be successful running Linkerd in production. If you have questions, obviously we're on Slack. Love to hear from you. I'd love to hear from you about this.
Yeah, absolutely. And oops. If anybody saw that appear and disappear, that would be me accidentally double clicking instead of single clicking. Just to make sure that people have that information. As Jason pointed out, if you have general questions about Linkerd, the Linkerd 2 channel and the Linkerd Slack is a great place to go for help out there. And other than that, I think that's about it.
Yeah. Well,
Last,
thank you so much, Flynn. Really appreciate it.
oh, thank you. Thank you to everybody who's watching and listening. As we mentioned earlier, this is our inaugural Restream experience. So we'd love to hear from people about how that worked out for them. I think that's about it. We'll be back here January of 2023. It's surreal. Happy holidays, everybody, and off we go.
Yeah. See you next year.